Hello everyone and welcome to this NPTEL online certification course. This is your fourth lecture that will be on hydrosphere. In the previous lectures we have discussed the global water challenges and some of the future solutions and visions that should be taken to develop our understanding on aquatic systems. Now, in this lecture we will talk about hydrosphere and the global hydrological cycle. To begin with the global hydrological cycle and to understand the processes, first we need to understand the properties and their importance in water. Okay. Now, there is in no way that we can overstate the role of water in sustaining life on earth, right. So, starting from life being formed in water to the maintenance of global climate and being as a resource to all the animals performing all life sustaining activities, water is the most important. So, naturally when we are trying to find out the presence of life in space, the first thing we try to detect is whether water is available on that planet. So, water is that important and it is the properties of water that makes it that life giving liquid, right. So, what are the properties and its uniqueness and what is its importance especially for the global hydrological cycle and in the controlling of the aquatic chemistry in different kinds of aquatic environments. Now, this properties of course we need to understand is because of the particular composition of water, that is hydrogen and oxygen, and the bond that is being formed between this oxygen and hydrogen, right. And the unusual these properties that I am going to be speaking about, that is melting and boiling point, density, surface tension, viscosity, latent heat of vaporization, latent heat of fusion, specific heat capacity and solvent capacity. These kind of properties, this is due to the polar nature of the molecules and it is mostly between the bonds that are formed between the adjacent water molecules and between the water molecules and other materials. Okay. This is the kind of bonds that are being formed that controls and maintains these properties. So, the first point is melting and the boiling point, that is extremely anomalously high for the molecular weight of water. Okay. What importance does this melting point and boiling point have on earth water cycle? It permits water to be in liquid state as well as in vapor state as well as in ice state on the earth's surface. So, on the earth's surface we can find water in all its three states of existence. Okay. There is water vapor in the atmosphere, there is always water vapor there in the atmosphere, of course there is liquid water on the surface, and in the colder regions you will find it in the form of ice. Density. Okay. Now, the density of water is maximum, it is there is a anomalous nature of water that it denses. Okay. It is maximum at 4 degrees, that is 3.98 degrees Celsius, that is not at freezing point, and then it expands. Okay. So, first it gradually becomes denser, but after as you lower the temperature from 3.98, then it starts again expanding. How is this important in terms of hydrological cycle? This controls the velocity of water flows, that means how water is flowing in different kinds of environments that is subjected to different kind of temperature, okay, the density of water is very important. So, as you know that in different areas of earth the temperature is different. Okay. So, in the tropical region the temperature is much hotter as compared to the polar regions, as compared to also to the temperate regions. So, we have the tropical region, we have the temperate region, and we have the colder Arctic regions. Okay. And at different places due to different phenomena, the temperature can change a lot. Okay. And there can be seasonal differences and all that. So, somehow the density of water, if it changes, it is reflected in the water flow. Okay. And also it is of extremely important for the sustaining of life, especially in lakes. Okay. Lakes in colder regions, okay, and in polar areas, they start to freeze when the temperature drops below the freezing point. But what happens is that once the surface water starts freezing, the conduction of heat, so that prevents it from the bottom of the layer to cool down further. And what happens is there is a lot of stratification in the lakes, there is thermal stratification in the lakes. Due to this reason, the dense water that is there in the bottom of the lake, that is that is not frozen, that allows the fishes to continue to live even when the outside the surface temperature is much below the freezing point of water. So, for the sustaining of life, density plays a very big role, specifically in the colder areas. Surface tension of water. What is surface tension of water? So, the water it is trying the force that is acting to create that spherical nature on the of a water droplet, that is the surface tension of water, and that is higher than most liquids. All kinds of liquids we have measured and all that, and these special properties of water makes it so useful. So, this how it is important, it controls the cloud droplet formation and for raindrop growth when it is in the when it is falling down through the atmosphere. It controls water absorption and retention in the soils. So, surface tension is extremely important. So, you may heard of this term called capillary effect. Okay. So, in between water particles, when there is a tension created, water moves due to this capillary force. Okay. So, water movement in plants and all through the soil, this is due to this capillary force, and this is due to rising due to this surface tension property of water. Another extremely important property is viscosity. What is viscosity? It is kind of it is like an internal friction due to the intermolecular forces that is there inside the water molecules. It is a kind of friction. So, there is a viscous nature. So, the resistance for the water to flow. Okay. So, it is a kind of friction that is happening, an internal friction. Okay. It is lower than most common liquids, and this controls the flow rates in porous media. The low value results in turbulence in most surface flows. Okay. So, some places you will see that there is a turbulent flow because of the high sometimes due to the high velocity and all that, sometimes there is a high turbulence in the flow. Okay. And also when it is moving through a media, that is it is moving inside the soil or inside as it is moving through the bedrock and all that. So, that kind of media when it is moving, what is the flow, what is the flow rate in those kind of media. Viscosity is a very important parameter. And if you are doing hydrology, groundwater hydrology, you would often be using this term called viscosity, and it is denoted as mu. Latent heat of vaporization, and it is one of the highest known values, that is 2.471 megajoules per kg, okay, at 10 degrees. So, this latent heat of vaporization, that is, what is this latent heat of vaporization? That means water at 100 degrees will take certain amount of energy to change its phase to water in the vapor phase. Okay. Now, when that kind of phase transitions are happening, those energy that is uptaken or released, those are called latent heat. Okay. And it controls the land to atmosphere heat transfer, because often you will see when water is there in the lakes and all, and it is so heat is there in the environment, and the climate is so hot, weather is so hot, that kind of in that kind of scenario, how much water will get evaporated to its vapor stage. If it was a liquid that had a low latent heat of vaporization, what will happen? With a little heat supply, it will turn into vapor phase, right. With little heat supply, it will turn into vapor phase. Then what will happen? You will not remain, nothing will be remaining in the water system, right, as water as liquid, it will all turn into vapor phase. Due to this high vapor latent heat of vaporization, water needs to absorb a lot of heat and then turn into vapor phase. So, this creates a balance between how much evaporation is going on and how much water is remaining as liquid form, and it also causes a lot of energy, okay, to be transferred, okay, in the atmospheric circulation, okay, because as you know, energy is neither created nor it can be destroyed, it can only be transferred from one phase to another, right. So, from the atmosphere and how it is going to the precipitation form and all that. So, this kind of controls is very useful due to the high latent heat of vaporization of water. Another similarly, latent heat of fusion is higher than most common liquids, and this controls the formation and melting of ice and snow. Again, what is happening is, you see that when water is turning into ice, it has to give up a lot of heat, okay. It has to give up that much amount of heat to turn its phase from water to ice, right. Now, that transition, the heat that is that has to be dissipated, controls the formation of ice and snow, okay. Again, that is very important in our hydrological cycle, in the movement of energy from one in causing such circulations. Specific heat capacity, again specific heat capacity of water is how much water, how much heat is required to rise the temperature of water, so per degree centigrade what is the rising temperature, and that moderates air and water temperature. That means, to increase the temperature of water by 1 degree, we actually need to supply a lot of heat, because it is one of the highest of any liquid except ammonia. Okay. So, it is one of the highest that we have seen in any liquid, and therefore, water can store a lot of heat, right. Solvent capacity, again it is beyond it's like we cannot ever understand how much important is the this particular property of water is to its maintenance of support of life on earth, that is the solvent capacity. It is an excellent solvent for ionic salts and all kinds of polar molecules, and it kinds of this property is one of the most important property because it helps us perform all the bodily organic functions. So, it is so important to for something to dissolve in water and for the reactions to happen, something else the products that is being formed, that those molecules can take some other shape, and these kind of reactions that has happened in the oceans in the past and everything, these are the processes that has finally helped life to happen on earth. And starting from all the global elemental cycles to all kind of enzymatic activities, all kind of life sustaining activities, everything is possible due to this high solvent capacity of water. It says that water can dissolve everything, all kinds of things. Some things dissolve within your eyes, in short time scales. If you see, sometimes it will dissolve in front of your eyes, and sometimes it will take forever for it to dissolve, but it will dissolve slowly it will dissolve. And now we move towards this global water cycle. Now, this global water cycle is a very broad term, okay, and this is a term that we use to understand how water is being transferred across the globe from one reservoir to another. Okay. There are multiple processes that is being acted and multiple forms are there, multiple aquatic systems are being formed in that kind of process. So, this is the global water cycle that discusses the transformation and movement of water across the globe. Now, this photo that this picture image I am showing you here has been taken from one of the very famous publication that came out in 2006, and it actually calculated it was the latest I think calculation of how much water is being transformed from the different reservoirs. Now, coming back to a little bit of introduction I would like to give is that about this branch of study called the hydrology. Okay. So, hydrology is one of the biggest and I would say is a very important branch of geoscience, and that describes and predicts the occurrence and circulation of Earth's water in different through the different aquatic environments. And it is not only the physical movement of water. Okay, so, it is not just water that is moving across all the different kinds of environments, but there is movement of energy, there is movement of matter, and a lot of processes specifically that is happening when these exchanges are happening. Okay. So, the distribution and movement of water on and under Earth's land surfaces, including its exchanges with the atmosphere, its physical chemical interactions with Earth's materials, and the biological processes and human activities that affect its movement, distribution and water quality. Now, in this figure you will see I'll slowly walk you through this water cycle. I am sure you have undertaken this in your school environmental studies classes, and you already may be quite aware of this. So, our starting point is the oceans, that is the sea, and you will see a certain number has been written, and as you can, if you follow here in this little space that is here, this is written, there is a storage, that is amount of water that is stored in that particular reservoir. And fluxes, okay. So, this is the flux terms, as you can see, and there is such arrows are there, okay. So, this is, that means there is exchanges happening. So, up is evaporation and down is precipitation, okay. So, the exchanges is happening, those fluxes are mentioned in 10 to the power 3 kilometer cube per year, that is per year basis. And sometimes the area also that has been considered, how much area has been calculated is also mentioned. So, water, okay, it starts from here, okay, it starts evaporation due to the incoming solar radiation from the sun, that is our source of energy for planet Earth. From that, the heat energy that is used to evaporate water from the surface of the oceans, it goes and it forms clouds, right. And most of the precipitation also happens into the ocean, and you may actually be surprised to know that almost 80% of the precipitation is happening. So, on the oceans, of course, you need to also understand it with the fact that land surface, okay, we always have from our school days we used to know that earth has 3 parts of water and 1 part of land, right. So, it is water covering earth's surface is 3 times more than the land surface. So, definitely the precipitation events that is happening on land will also be much more higher on the oceans as well. So, it is whatever is evaporation is happening, 80% of that evaporation is again going back into the oceans. And from the clouds that is being formed over the oceans, it starts moving towards the land, and as soon as it starts moving towards the land, it gets cooled at certain places, and as it cools, it starts forming water droplets, it starts growing, and once it is not able to hold the water anymore in the atmosphere, then it starts raining, and it can rain in the tropical places and the temperate places, and when it is in the much colder zones of earth, it might actually start snowing. And sometimes you see this even in the lower latitudes, but with very higher elevations, like if you are going to the Himalayas and all, you will see snowfall, that is because of the higher altitudes. So, on the mountains and at very colder latitudes, that is higher latitudes, we will get snowfall. And this precipitation that is happening on the land, okay, the either it is in the form of rainfall or it is in the form of snowfall. Now, snow also, if it gets stored, that means it is forming snow packs, and it is if the snow packs, if they are stable and if they are staying stable for very long period of time, it will form an ice mass and it can form a glacier, okay. So, long term preserved snow becomes ice pack, which grows into glaciers. If they are big enough, they will be termed as glaciers. So, this but again it will melt, okay, during warmer seasons, or with now since we are during the interglacial period, it will start melting, and when rainfall or ice water, snow melt water, when this melt water is again draining the terrestrial system means all the land based system, okay. So, it can come down as runoff, okay. Runoff can get infiltrated. So, if it gets infiltrated into the soil, then it will it will form groundwater, or if it goes to if it is a lot of rainfall is happening which is beyond the infiltration capacity of the soil, then it will flow as overland flow and it will enter the streams. These streams can again start joining, it will form large rivers. These large rivers again will finally drain into the ocean. okay, and in between, so this water gets stored also in the terrestrial systems into the groundwater. So, as groundwater it gets stored, as lake water it can get stored, it can get stored as biological water in the plants and in all kinds of other life forms. So, there is biological water is there, and wetland systems. Now, what are wetland systems? So, wetland systems, there are a lot of aquatic plants are growing, but it's not really a lake, but there is a certain a significant proportion of water. So, water will always be there, and a lot of grasses, a lot of aquatic plants will be there. So, those kind of areas, and of course, a lot of human uptake is there. So, in the industry how much is going, in the domestic how much is going, in the irrigated grasslands, non-irrigated grasslands, non-irrigated agricultural components, how much that kind of water is getting divided and uptaken, that kind of finer calculations are also taken care in such kind of studies. Now, as I move deeper into the hydrological cycle, I will start dividing it, okay, and I will start first with the time and how much the reservoir is and all that, because we need to understand the scales that we are working, and that is both spatial scales as well as temporal scales. Okay. So, the hydrological cycle is, again, it is extremely important for the earth's climate, and for all time scales. What do I mean by at all time scales? That means even from day to day scale to monthly scale to yearly scale and to the long term like 30 years, 40 years to millions of years of scale. Okay. So, from local scale and again to global scale. So, what is the temperature at a particular location, that is very local, and all across the globe hydrological cycle is the controlling component that maintains this climate. And this particular image shows the variations in the time scale on the x axis, and on the y axis you have the aerial scale. So, as you can see, the time scales begins from seconds and then goes to minutes and days, years, century, millions years and billions of years. Okay. And here are certain different kinds of events mentioned of the different scales and how much area it covers. So, for instance, there is a thunderstorm. Okay, a thunderstorm can take an aerial extent of roughly a kilometer or a few kilometer, and it can be for a few minutes, okay, or that continuous thunderstorms and storm activities can continue throughout the few hours of the day, right. So, that is the time scale and that is the aerial scale. During thunderstorm process, of course, you must understand it is a rainfall event is happening, lot of energy is being exchanged with the atmosphere and the land. Then mesoscale weather systems, for some instance floods. Okay. Sometimes floods can also happen which will be for a few days. So, it is raining extremely high, okay. Suddenly it started raining for a few hours, and now you are in a choked system, the water is flowing nowhere, it is getting stagnant there, and therefore, you have a flood. Okay. Or it may so happen that there is a river and the river has flooded, and therefore, within a few hours a lot of water can occupy the entire catchment, and the scale can vary from anywhere from tens of kilometers to hundreds of kilometers, and that can happen within a few hours to a few days, right. Now, moving to a little higher in terms of time scale and all. So, nutrient cycles. Okay. Now, nutrients again I will describe later what are nutrients, but as you the term implies, nutrient is something that is nutritious to our body, is extremely important for our bodily functions. By our I mean not only humans, by our I mean all kinds of life forms, and that includes plants, that includes all kinds of fishes and animals and all. Okay. And cycle, by cycling I mean the nutrient cycling within the atmosphere, the hydrosphere, the biosphere, the lithosphere, that kind of cycling I am talking about. So, the nutrient cycle that is happening in terms of yearly scales, because the turnover rate is much faster, alright. So, it can happen within a few years. Okay. So, the nutrients when I will be talking about the nitrogen cycle, the phosphorus cycle and all in subsequent lecture classes, then I will be talking about their scales, how it is being transferred from the atmosphere to the lithosphere via the biosphere, via the hydrosphere, and again it is getting released back to the atmosphere. So, that kind of cycling of any particular element, an element something like nitrogen, which is one of the blocks of life. Okay. So, that kind of cycling that is happening, and the scale that it is happening. So, it is happening within a few years scale, and in terms of locality it can happen within a few kilometers. Okay. And of course, that now again depends vastly because of the global what I will call the global movement of crops and everything, but roughly we consider everything in that local scale that is available, we consider it as in the when we are trying to calculate nutrient fluxes in a particular local area, state or country or things like that. Or soil moisture variation, how much that is happening, that is happening within a few years. Okay, whether the soil is gradually losing its moisture, the overall moisture that it has, and that scale that is happening for a large scale like a 50 kilometer square kilometer catchment, how is the soil moisture changes are happening. Runoff cycle is more in terms of rivers, and so rivers are not initial when the rivers are starting in the headwaters, they are not like huge. Slowly, due to the joining of all the tributaries of all the streams of all the lower order streams, then we get the river as a huge river, but initially it starts as a runoff, right. So, it starts as a runoff, which can vary in between the scale of few kilometers to hundreds of kilometers, and then it can finally take the shape of a river that can be of 1000 square kilometer like that area. And of course, the turnover scale of that river starting from its journey from the headwaters to its sink in the ocean, that is the time scale of runoff that is being formed. And from that kind of time scale we can move towards more slower processes, such as shallow groundwater circulation. Groundwater movement, water infiltration and movement towards the aquifers, it can sometimes be fast, it can sometimes be slow, depending on the media, that is the porous media, and a lot of other parameters. And this roughly has century scale transmission is happening. So, how water is being accumulated in the aquifer, and again it can have from a small scale, that is something of tens of kilometers to hundreds of kilometer scale, or something which is of a very large time scale, such as the development of major river basins, that can actually take millions of years. Why millions of years? Because tectonic events are happening, valleys has to be formed, uplands has to be formed, there has to be a slope created, and climate may also get altered in that time. So, formation of a very well developed river basin can actually take millions of years. And in terms of global, the highest level of global scales, we can see, the weather system, the elemental cycling system throughout the globe, that will be my largest spatial scale. Okay. So, global here, an example has been taken of carbon dioxide variations, that is basically through the atmosphere and water all across the globe. Now, while water is being circulated, okay, it is also getting stored onto various terrestrial storages, and here the stock, the global water stocks are mentioned in terms of area and volume, and you may actually see that the fresh water system is actually very low. So, it is only 1.1% of the total water that is available on earth, right. And if you see in terms of rivers and lakes, how much it is a very minor fraction, that is 0.013 fraction of the total water that is available on earth. And of course, I think you already have known these kind of numbers since your school days, that the oceans actually are the major storage of water on earth's surface. And why I am talking about this kind of stocks, why I am talking about this kind of values and all that, it is because oceans is a final sink. Okay. Oceans is a final sink, and it is the extremely important for sustaining of life on earth. It is absolutely necessary to maintain the ocean health. But the other stocks that I am going to talk about, that is, say suppose for instance the rivers, the lakes, the glaciers, groundwater, soil moisture, they actually allow all the terrestrial activities to happen. They are actually the reason why continuous we are some processes are happening, and there is elemental exchanges are happening, and that is, even though a small number in terms of stock value and all that, it plays a extremely important role in the global water cycle, not only global water cycle, but into the elemental cycling and for making life happen on earth. Now, global water cycle, there are multiple processes that is happening, and I am sure you must be knowing these important processes, such as evaporation, that is, water is getting evaporated from its liquid state and moving to its vapor state. Transpiration via plants. Condensation, again water when it is moving to colder areas, it will see the drop in temperature, it will start condensing and it will form again water, and it will get precipitated as either rainfall or as snowfall. So, first there is condensation and then there is precipitation. Now, after it precipitate, what happens? It will either go as runoff. Okay. And so, what is runoff? I will describe in the next few slides I will start describing the importance of runoff. And infiltration and evapotranspiration are maybe two more important processes that you may not have heard of in in different previous things that you have taken. Infiltration, what is infiltration? The amount of water that is moving through the soils and reaching the groundwater storage. Evapotranspiration, again what is evapotranspiration? Evapotranspiration is the amount of water that is lost due to evaporation of the tiny droplets of water from the plant's leaf surfaces and all. So, the plants, they are transpiring and that is getting evaporated and it is going back into the atmosphere. So, that evaporation and transpiration together we call evapotranspiration processes. Now, this image that I am showing here is the principal storages that I have talked to you about, and how water is being moving through this system. Now, I will stop this lecture here and I will move on to describe this and therefore, the subsequent cycles, sub cycles of water cycle in the next lecture. Thank you.